Hello, we introducing the set theory in this video. So, set theory means the different kind, how to describe a set, different forms of set, different kinds of set, then operations defined on sets, and laws on sets, Cartesian product, etc. Okay, so first of all, what is mean by a set? A set which is the well defined collection of objects. Well defined collection of objects is called sets. Okay, generally, if we want to take some objects, like there is pen, which is the first object, pencil, table, something like a bottle, which are some like objects, right? We are ordering these objects by separating them using a comma and starting and ending with a curly bracket. This is the definition of a set. That's it. So set is meant by we are collecting some objects and we are arranging in curly brackets. So it must be open and closed by two curly brackets, and the objects must be separated using a comma. Okay. So that is a set. So this is a kind of set. And the set is generally naming as in capital letters or uppercase English alphabets like A, B or C. These are the name of or the representation of set. We have to give a name using the uppercase letters of English alphabet. Okay. Now if I can select the numbers or something like even numbers, odd numbers, natural numbers, integers, we can all these things arrange in a set. So this is actually the definition of set. I think it is clear. And if I am picking the numbers from 1 to 5, the natural numbers from 1 to 5. So before that, we have to explain what is mean by the natural numbers, set of all integers, rationals, irrationals and real numbers. After that real numbers, we can define the complex numbers and also. Okay. So the first thing I want to explain the number system. Some number systems which I explained, because if I want to moving to the next concept about the set theory, which is two different types of set representation. In set builder form, it will be very helpful for describing the set, and we can find the other form of set using the set builder form. Okay. So the number system, which is start from the natural numbers. Natural numbers is generally represented by n, and not that we are representing the natural number by a one more line in here or here, anything like that, and which is read as script n. Okay. And the natural number system is perfectly defined by it is the collection of countable numbers like 1. Then we will count it as 2, we will count it as 3, 4, 5, something else. And that is the natural number system. Okay. Not that the natural number system is again in a curly brackets and the numbers are separated by the comma. So actually this is a collection of objects which is from 1, 2, 3, etc. up to goes to anywhere, like it is naming as infinity. It just goes to infinity. Okay, infinity. And And next we have the set of all integers. Integers is generally represented by z. In some textbook they are representing it as by I. Both are the same, which just indicates the integers. Integers means we are considering some more elements than the natural number system. Like the entire natural number system belongs to the integers. That means we have 1, 2, 3, 4, etc. And we are including the 0 here, okay, 0, and the negative of the natural numbers, which is minus 1, minus 2, minus 3, etc. up to negative infinity. Okay. So this is the set of integers, and we have the rational numbers. Rational numbers is generally represented by Q, and which is the collection of all P by Q formed numbers. Not that the denominator not equal to 0, and this P and Q, which is from the set of all integers. So the numbers be like minus 1 by 2. These both the numbers are from the integers, and the denominator is not equal to 0, and we can select a 3 by 4. This kind of numbers are belongs to the rational numbers. Simply it is the rational numbers. Okay. Now we have the irrational numbers. Irrational numbers, they are the collection of irrationals like root 2, root 3. We cannot express these numbers into a P by Q form, then it is called irrational number. Okay, which is cannot expressed as in a P by Q form is known as irrational numbers. Then we have the real number system, real numbers, which is represented by script R, and which is the collection of all Q and the irrational numbers. The combining of irrationals and rational will give you the real number system. Okay. So it is of the form, if we are selecting the entire natural number system, integers, rational numbers, irrational numbers are all included in the real number system. And I can express like in a Venn diagram system. So when we are coming to the Venn diagram, I can explain this into like a Venn diagram expression. So that's it. These are the number systems. So I think it is clear that the natural number system, integers, rational numbers, irrationals and real numbers. Now we are selecting the collection of all elements from the natural numbers from 1 to 5. Okay, 1 to 5, and I can arrange it be like 1, 2, 3, 4 and 5. So this is another kind of set, and I am just naming it as B. Now if I am selecting some vowels from the English alphabet, then I am just taking the set C, which is the collection of all vowels, which is A, E, I, O, U. So the objects must be separated by a comma and should be included in 2 curly brackets. Okay, that's the set. Okay. Now the objects is mathematically called elements of the set. Elements of the set. Okay. So if I am selecting the B set, I am considering the B set, and if I am selecting 1 is an element of B, right? Element of B. Simply it can be expressed as in the form of 1 element of, which is represented by this kind of a symbol, and 1 element of B. or 1 belongs to B is also fine. Belongs to B. 1 is an element of B or 1 belongs to B so as well, and the simple is notated by like a curve like an E. Okay. Next we have 2. If I am picking 2 is an element of B also, so I can represent it as 2 is an element of B or 2 belongs to B. Now if I am selecting a 10, can you see the 10 in that B set? No, right? So 10 is not an element of B, and which is represented by 10 is not 10 element. So you just put a bar or a cross line for that corresponding belongs to simple, and this is the representation. 10 is not an element of B. And if I am picking 7 is not an element of B, so that I can simply represent it by 7 is not belongs to B is also fine. Not an element of B or belongs to B, both are the same. That's it. So we just named as what do you mean by a set, how we can have expressed the elements of a set, and the symbol used for the element. And if we can pick the objects like this, or 1 2 3 4 5, we can simply find that which are the elements that belongs to a corresponding set, which is the form is called the roster form of set. Roster form. From that set we can simply say that what is the elements are. Okay. So I have already explained that which is the roster form, and we can move to the next form, which is set builder form. Set builder form. So builder means we have to build the set B like a story. Okay. Set builder form. If I am selecting the set builder form, if I am getting the naming as, we have to get a naming ceremony for a set, and which is A be the set. So this is the set. Okay. And this is the set of elements or set of the objects, and we don't know what are the objects here. We are giving a general form or general information or general characteristic of a element. Okay. So in general it is represented by X. So we don't know what is X. Now we have to give some characteristic forms for that X, and we will find what will be the corresponding set. So the set builder form means we have to build in a sentence which kind of objects belongs to that set in a sentence way, that is called set builder form. Okay. So if I am selecting X be like 1 less than or equal to X less than or equal to 10, and X belongs to the natural number system. Okay. So this is the representation of X or the characteristic of X. What is mean by the natural number system? We are taking the counting numbers like 1, 2, 3, 4, etc. belongs to the natural number system. And they are giving one more condition, which is x can be taken the value from 1 to 10. 1 and 10 are included in the set. If we are taking the equality simple, we have to include that numbers also, and in between which are the numbers are in between 1 and 10, that also we have to consider for this set. So how can we express in a this set into the roster form? So this is the set builder form, and we can write it as a set roster form. And what about the roster form is? Again, it is in the curly brackets. Yeah, we have to start with 1 and we have to up to 10. I don't think so. All the elements which can be expressed in such small brackets. So that's it. And from that 1 and 10, the counting numbers are, after 1 we have 2, then we have 3, then we have 4, 5, 6, 7, 8, 9, up to 10. This is the roster form of this corresponding set. Now if I am taking in another set which is B, again it is a general form, so we have to select it as collection of all x such that, and we have to specify the characteristic of x. If I am selecting x as a vowel from the English alphabet, then how can we express? So we know that which are the vowels from the English alphabet. That is in a roster form, which is the first one A, then we have E, I, O and U. This is the vowels in the English alphabet. So this is the set builder form and this is the roster form. If I am giving a roster form and we have to convert that into the set builder form, if it is 1, 3, 5, 7, 9, how can we express this into the set builder form? So set builder form, which is I am giving the set name as capital C, and which is the collection of all x such that, what is the specification of that set? The set containing the odd numbers, right? Odd numbers from where to where? From 1 to 9. So we can simply express it like this. X is an odd number, comma, it is not ending, because if we are given only like an odd number, it is goes to like 1, 3, 5, 7, 9, 11, etc. And we have to get a stop at 9 and we have to end at start with 1 and end at 9. So how we can express, like this is 1, which is our starting point, and we have to include, so less than or equal to x, which is less than or equal to 9. That's it. So we are picking from 1 to 9 all the numbers, and which must be an odd number also. So we can eliminate that. If this one is our, if we are focusing on this one, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is mean by this. And if we are giving the extra additional information, which is an odd number, then we have to eliminate this even numbers and we get the corresponding roster form. That is the answer. Okay. I hope that you got the concept. So there is a homework for you, or you can do the answers for this kind of sets, which is A is equal to, for the first one I am just giving the set builder form, for the second one I am just giving the roster form. So you have to convert the set builder into the roster into the builder. Okay. So I am just giving the collection of all x's such that x is a prime number, and which is from 1 less than or equal to x less than or equal to 20. And the second one, b is equal to collection of all f, l, o, w, e, r. Okay. So I want the answer in a roster form and in a builder form in the comment section. Okay. So these are the two forms of sets. So there is two types of sets, which is set builder form and set rostering form. Okay. Next we have different kinds of sets. What is meant by different kinds of sets? There are so many kinds of sets, and we have to explain what they are. Okay. So I want to explain the first kind of set, which is a null set. Null set means an empty set. So it can also be named as an empty set. Okay. Empty set means there is nothing in that set. Okay. So simply the representation of this empty set or null set is either it is a Greek letter, which is a phi. Okay, phi. Or we can simply taking as a set with no elements. So this is also representing for the empty set or null set. I can give you an example, which is the set of, I am just taking a collection of all x such that in a set builder form, x is a living dinosaurs in this world. Can you find a living dinosaur in this world now? No, right? Living dinosaurs are not existing now. So this is an empty set. So this is empty set. That's it. And the collection of all, the set of all prime ministers in India before 1947. Is there any prime ministers before 1947? No, right? So this is also a null set or an empty set. Both are the same, okay? The null set. Now we have the next kind of a set, which is Singleton set. What do you mean by Singleton? It is a single kind of set, only contain one element. So you don't know what is the meaning of contain. So I am just deleting that corresponding word, and I will explain what is mean by contain or contained in, like that. Singleton set means a set with only one element. Like if I am selecting a set with only one element, which is 1. So there is only one element and it is known as a singleton set. Or we can take another set, be like Z, the 26th letter in the English alphabet, which is set. So these two sets only containing one element, and we can simply say that it is a singleton set. Okay, only single element, which is singleton set. Hope you get that point. Next we are moving to what is mean by a finite set and an infinite set. Finite set. What is mean by finite? A set with a finite number of elements is called finite set. Okay, set with finite number of elements. What is mean by a finite number of elements? We can stop at a particular stage, like there is only 10 elements, or there is 100 elements, or there is 500 elements. We can count them in our in a certain way, that, and we can say it is a set with 500 elements, a set with 1000 elements. So we can fix a number to count the elements in a set. So in that way, or if we can express the number of elements in a certain way that it is a finite number, then it is called a finite set. For example, if I am taking A is equal to 1, 2, 3, 4, 5, 6. How many elements are there? There are 6 elements, right? 6 elements. So we can fix the number of elements as 6. There is 6 elements in that corresponding set. So we can say that this is a finite set. This is a finite set. So for a finite set, the number of elements is represented by n of the corresponding set, which is 6. If it is a number like a finite number, then the set will be a finite set. That's it. Next, in this kind of a set, we have another one, which is infinite set or infinite set. So what do you mean by an infinite set? We cannot fix a particular kind of number for representing what is the number of elements in that corresponding set. In that cases, we are taking the set as an infinite kind of set. Not that a set which is not finite is called infinite set. A set which is not finite, then it is infinite. So can I say something that if B is equal to the null set, or simply like this, can you identify it as a finite or infinite set? The number of elements in a B is equal to a fixed kind of a value, be like a finite number, like 0. There is no elements, so 0 elements are there. No, which is 0. So 0 is a finite value. So null set is a finite set. Okay. The example is taken as our natural numbers or integers, real numbers, rational numbers. Any kind of number system is an infinite set. The natural number system is counting like 1, 2, 3, 4 and going into and moving as many as possible. So can we fix that there is only 10,000 elements? No, right? After 10,000 we can count like 10,001, 10,002. Okay, so we cannot fix a number of elements in the natural number system, so it is not finite. So it is an infinite set. Infinite set. Okay. Next we have what is meant by a disjoint set. Disjoint sets. Disjoint means they are disjoint. If I am taking A is equal to 1, 2, 3 and 4, B be the set which is 4, 5, 6, 7. The number of elements which is there any common elements for A and B? Yeah, there is 4 which is common for A and B, right? So there is a common one. If there is common one, then the sets are not disjoint. So what do you mean by disjoint? There is no element is common for any kind of sets A and B. Then we will say that sets are disjoint sets. If I am taking A is equal to 1, 2, 3, 4 and B is equal to 5, 6, 7. Now we are considering the elements of A. They are 1, 2, 3, 4 and which is entirely different from the B's elements which are 5, 6, 7. So there is no common elements for them and A and B are disjoint. They are disjoint. So if they are different, there is no common values for each of them, then we will say that the sets are disjoint sets. Okay. So that's an example. As two sets or any kind of sets, we can make it into 3 or 4 or something. Two sets which have no common elements, then it is disjoint sets. Okay. Now we have the next one, which is subset. If I am taking a set P, like A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4. Okay. Then if every element of A which is also in B, then we will say that A is a subset of B. A is a subset of B. If every element of B belongs to or are common for B also, then we will say that A is a subset of B. Okay. In this case, we will say that A is the subset of B and B is the superset of A. A is the subset of B, or we can say that B is a superset of A. Okay. B is the superset of A. So can we say that A is equal to set 1, 2, 3, which is a subset of A itself? A is equal to, in the place of B I am selecting the A itself. Then can we say that A is a subset of A? Yes, because every element of A, 1, 2, 3, are the elements of B also, right? Are the elements of A also, 1, 2, 3. So if we are taking the same set A and itself, they are subset of each other. And we notating like, in this case, we will write it as A is subset of A itself. Okay. Now we have the concept which is proper subset. Proper subsets. For this case is also fine. If I am selecting the A and B like this, proper subset means every element of A must belongs to B and some more elements which does not belongs to A which is in B. Then we will say that A is a proper subset of B and which is notated by this symbol only. For this case, all the elements of A which are 1, 2, 3 belongs to this B set, right? 1, 2, 3 are belongs to B set. But B has one more element than A which is 4 which is not belongs to this A. So B containing all the elements of A and 1 or 2 or more elements than A, then we will say that A is the proper set of or proper subset of B. Okay, proper subset of B. If I am taking A is equal to AB and B is equal to A, then how we can say that the subset definition for these two sets? B's elements are belongs to A, right? This A belongs to this A. So we can say that B is a subset of A. But more than that, we can find one more element in A, right? One more element in A which is different than B's element. So B is not equal to A. So simply it is a proper subset of A. So this is the difference between the proper subset and subset. Okay. And if we write a set like 1, 2, 3 and if I am taking B as itself 1, 2, 3, then the all elements in A are belongs to all the elements in B. There is no elements more in A or B. So simply it is, we are representing by A is a subset of B. Or we can say that it is like B is a subset of A itself. Both are the same in this case. Okay. Now we are moving to the next set. So in the concept of subset, we have subset and proper subset. Okay. Next we have equal sets and equivalent sets. Equivalent sets. So what is mean by equal set? Equal set means if there is A and another set B, if I am taking the set as 1, 2, 3, 4 and B is as itself 1, 2, 3, 4, then the elements in A and B are the same and the number of elements is also same. Then we will say that they are equal sets. So equal sets means n of A and n of B must be the same and elements also same in A and B. Then we will say that they are equal sets. So what is meant by an equivalent set? Equivalent set means the elements should not get equal, but the number of elements should be equal. If n of A and n of B are equal, then this condition does not hold for equivalent sets. And the equal sets are always equivalent sets, right? So if n of A and n of B are the same, then the sets are called equivalent sets. If I am taking A is equal to 1, 2, 3 and V is equal to A, B, C. The elements are extremely different. They are disjoint sets. But n of A is equal to 3 as well as n of B also. Hence, these sets are equivalent sets. Okay. Next, the last concept of set or different kinds of set, which is comparable and incomparable sets. A comparable sets means if we can compare them, like if there are two sets which are A and B, if we can say that either A is a subset of B or B is a subset of A, any of them follows, then we can say that A and B are comparable sets. For example, if A is equal to 1, 2, 3 and B is equal to 1, 2, then we can say that B is a subset of A and moreover that B is a proper subset also. Okay. So the second one is holding here. So the given A and B are comparable sets. So what do you mean by incomparable? If we cannot compare them, then it is incomparable. That means neither A is a subset of B nor B is a subset of A. The both condition does not following, like we cannot say A is a subset of B or B is a subset of A. Then they are incomparable sets. For example, if A is equal to 1, 2, 3 and B is equal to ABC, they are different or disjoint. So if they are disjoint, we cannot say that A is a subset of B or B is a subset of A. Hence, we cannot compare them, and this is an example for the incomparable sets. Okay. Next, the concept which is power set. Power set. So, power set means if there is a set S containing some elements, the power set is be like collection of all subset of that corresponding set. Okay. If S is equal to 1, 2, 3, power set means the collection of all subsets of a set is called power set. If I am selecting, I'm just starting from a basic kind of set, which is this is only containing two elements or one element, or there is only one element, which is 1. Then the power set is defined by P of S. Okay, P of S. And I want to include one concept that the null set is a subset of every set. Subset of every set. And we know that if there is a set A, that itself is a subset. Okay. So the power set considering null set, which is a subset of every set. So we can enter be like the phi, comma, and there is only one element, and for that one element, how many subset we can make from that one? Only we can make that itself. So this one is the power set of S. If S is equal to two elements like 1 and 2, then what will be the power set? Power set contains the empty set, the full set, and the subsets. How we can express the subset of set 1, 2? You pick one element from this 1, 2 and get that into a set kind of a way. So 1 is in a set and the next element 2 is in a set. That's itself. Okay. And simply we can rewrite it as the general form of a power set, which is we write in a way that we using the null set, then the singleton sets, then if there is two sets, then that it is, then the full set. Full set is in the last and null set is in the first. Okay. Then if there are three elements like 1, 2, 3, how we can express the P of S? First we have the null set. Instead of 5 we can use the empty set. This is also fine. Then we will consider each singleton set. Set 1, set 2, set 3. Not that every element should be or every set should be separated by a comma. Now we are considering the elements with the two elements. So for that I'm just taking the first two elements. So it is 1, 2, right? 1, 2. In a set there is two elements which is 1, 2. Then I'm just taking the combination with 1 and 3. So it is 1, 3. So 1 is combinated with a 1, 2 as well as 3. And the next possible way is 2 and 3. 2 and 3. And is there any possibility for writing 3 and 2 or 3 and 1, etc.? No need of that, because the set 3, 2 and the set 2, 3 are the same. Okay. The alteration doesn't means that the sets are different. We can write it as 3, 2 or 2, 3. Both are the same. They are equal. So there is no need to write the alteration or the reverse of these elements. So I'm just erasing this. We doesn't want that. Next, the combination of two elements are getting over. Now we have the 3 numbers combination, which is the full set, and we can close it. Okay. Now I'm giving the fourth one, which is 1, 2, 3 and 4. How I can express the power set? First of all, we will write the empty set. Then the singleton sets, which are 1, 2, 3, 4. After that we will consider the combination of 2. So I'm starting with this 1 and 2. Okay. Then 1 and 3. So keep an order. It will help you that considering all the subsets. Then 1 and 4. Then the combination 1 with every element is over. Then I am just going to 2 and 3. Then 2 and 4. There is no need to write 2 and 1. They are 1 and 2 itself. 2 and 4. 2 is combinated with each of the elements in that corresponding set. Then 3 is combinated with 4. Okay. Now the 2 concept is over, or the 2 subsets are over. Now we are moving to the 3 element powers subsets. 3 element set. So the first one I am just taking it as 1, 2 and 3. 1, 2, 3. Then I am just hiding this 3 and I am just taking 1, 2 and 4. Okay. 1, 2 and 4. So first I am hiding this 4, then I am hiding the 3. Now I will hide this 2, okay, 2. Then it is 1, 3, 4. So it is 1, 3, 4. Next I will hide this 1, then I will get 2, 3, 4. This is the combination of 3 elements. So the 3 elements are getting over. Now we have the 4 elements, which is the full set, okay. That's it. Now we can analyze the number of elements in a power set under sets. So in this set, n of s is equal to 1. N of p of s is equal to 2 elements are there. If n of s is equal to 2, then in this set the number is 4, right? So there is a relation between them. If it is 3, then here it is 1, 2, 3, 4, 5, 6, 7, 8 numbers are there. Okay, so 2 is related with 8 something in a certain kind of way. And if it is 4, then the P of S contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 elements are there. So actually this is 2 raised to 4, 2 raised to 3, 2 raised to 2, and this is 2 raised to 1. Am I right? So this is, if the number of elements in the set is 1, then the power set has 2 raised to 1. If the number of elements in the set S is 2, then it is 2 square in power set elements. If the number of elements in S is 3, then P of S has 2 cube. If it is 4, P of S has 2 raised to 4. So in general, if S has n elements or m elements, then the number of elements in P of S will be 2 to the power m, or 2 to the number of elements of S. 2 to the power m will be the answer. Okay, and I want to add one thing, that the repetition of numbers is not good for us at all. The repetition is not need for a set. If the elements like 1, 1, 2, 2, 2, 3, 3, 3, 3, it's actually which is 1, 2, 3. If there is a repetition of numbers, which is no need for a set for expressing that. Okay, so the repetition is no need for a set. That's it, the different kinds of set. Now for the next session we can move to the operations on sets. Okay, thank you.